topic 2. We've got a summary here of some trigonometric transformations. Okay, so the first thing we need to do is recognize the base trig function that we're working with, i.e. sine, cosine, cotangent, whatever it happens to be. Make a quick sketch of the graph of this base function, including a few periods worth of x-intercepts and y-intercepts, location of any maxima, minima, or asymptotes. Okay. Then rearrange your new function into its generic form so that you can find a, b, and c over b. So you get that b factored out. Make sure you factor that out. And then your d. Okay, then, well, like we've done in the last couple, stretch, shrink, or flip the graph of the base function horizontally according to b. We work from x out, so we're going to do the b part first. So if b is less than 1, that means that we are stretching horizontally by a factor of b. If b is larger than 1, we're shrinking horizontally. And if b is less than 0, negative, we're reflecting across to y. Okay, so do those things. Then, okay, I usually do my phase shift next, but we can definitely deal with the A's next. That's fine. So then we're going to stretch, shrink, flip the graph vertically. Again, the previous part was all horizontally because those were interchanges, stretch, shrinks, and flips. Next, we will stretch, shrink, or flip vertically according to A. Sure. So if A is less than 1, shrink. If A is greater than 1, stretch. And if A is negative, less than 0, then reflect across X. Okay, furthermore about A, only if you're talking about the sine or the cosine functions, then you can talk about the amplitude, the absolute value of A. You don't use the word amplitude to discuss the other functions because they go infinite, just sine and cosine. Then we would need to do our left-right shifts and our up-down shifts. So left-right shifts first, because they're inner, they happen first. Okay, so we have our horizontal shifts according to C over B, and so they are the left and right shifts depending on if you have the minus or the plus. So the left shifts, it says less than 0. What it's meaning is it's going to look like x plus C over B, because that has a negative in it. And if it's a right shift, it's going to look like x minus C over B because it has a negative positive in it. So the left shifts and the right shifts. Then we can summarize that our phase shift of the graph is defined to be that absolute value of C over B. Lastly, we have the vertical translations. So we're shifting up or down by d units. So if d is less than 0, you shift down. If d is greater than 0, we shift up. All of those things together, hopefully not too many of them, or we've got complicated graphs, and we've got a graph. So let's take a look at the next one where we do have lots of those things and discuss all of them. And then we'll verify the result graphically. But thankfully, they didn't ask us for x-intercepts because those are not on this list, of course, and if I have to find them, much more complicated to find than just the translations. So, I can find them if I have to, but in the meantime, let's find the things that are asked for here. We just want the nice things, the easy things to find from A, B, C, D. So A is 2. B is, oh, I don't know because it's not factored out, but it's 1/2, right? Because you have to see it as a coefficient. So this is 1/2 times x. And if I factor it out to find C over B, I get minus pi right here. So C over B is negative pi. So C itself is pi halves, but C over B, when I divide pi halves by 1/2, I get back to pi, and then D is 1. So the amplitude is 2. The period, it's a cosine function, so the period was 2 pi, the original, so if I divide it by b, 2 pi divided by 1/2, that's going to flip and multiply. So 2 pi divided by 1/2 is 4 pi, or 2 pi times 2 over 1. So 4 pi is the new period. Then the phase shift. So it's c divided by b, pi halves divided by 1/2, or pi. As you can see up here, the phase shift is what we have in the factored version because that's c over b. Okay, so using the steps, that made me draw it. Predict the graph by comparing the amplitude, period, and phase shift without the basic cosine function. Verify my results graphically. Phase shift pi. Okay, so here we go. The original graph of cosine. So let's dot in our markers. I'm going to label all of them this time. So we've got our pi halves, we've got our pi, we've got 3 pi halves, and we've got 2 pi. I'm just going to draw the positive side for now. So it starts up at 1 and then goes through 0, down to -1, back to 0, back to 1. Okay, sometimes it's nice just to see a little bit, so I'm going to change my mind and draw just a tiny bit on this side because some of that is going to be shifting and we want to be able to see everything on the axis after I've shifted. So this got me to -pi on this side at least. Okay, so I'm going to draw on top of it to do one thing at a time. So the first thing that we're going to do is the like step 3 says, we're going to do the horizontal stretch shrink. So because of the b value of 1/2, it's going to be a stretch. The period's going to get to 4 pi. Okay. So that means that I'm only going to get to half of this. Let me finish drawing this now because I want my full I want my full 2 pi back up here. All right. I was trying to just do the positive part, but with that phase shift, or that, sorry, that period, I can't. Okay, so I've got to make this really fat, or really stretched out here. I'm going to stay at 0, 0, but each of these is going to get bigger. So instead of pi, I'm not going to get to that bottom part until twice as far. So I'm not going to get to that bottom part until 2 pi. So my graph is going to be really nice and wide here. And then same thing over here. I'm not going to get to that bottom part. So I don't even have a full period. Well, yeah, I do. Going up, going up. I have 1 period now. I used to have 2 periods graphed in light blue. Now I have 1 nice fat period right there graphed in dark blue. Okay. Then we're going to do the stretch, the vertical stretch of that 2, step 4. So all I have to do is make my y-axis go up to 2 and down to -2, and then I can go through the same x-intercepts, and I have that graph. Okay. I think that's all I probably should do on this graph, but I'm not far. I'm almost done. Let's phase shift by pi. Okay, so a phase shift by pi is going to take everything and shift it to the right pi units. So I'm going to draw another pair of axes below here. So I've got my -2 pi. We've got our -pi. I'm not even bothering to put the other tick marks for right now. We've got our pi, and we've got our 2 pi. I just want to line it up. Okay, so I'm going to, that's going to be 2, and that's going to be -2. I don't have room for anything more. And so we're going to shift to the right pi. So just the 2 pi marker shifts over to pi, so that's going to be down here. The pi shifts over to 0. The 0 shifts over to pi. The pi shifts over to 2 pi. And if I had 3 pi on the list, the 2 pi shifts over to 3 pi. So this looks like this. All right, and then finally we have a vertical shift of 1. So what that's going to do is drop our y-axis down to here. And so we're now changing our labels to -1, 0, 1, 2, 3. And this is now our x-axis. So it's no longer symmetric around the x-axis, it's symmetric around y equals 1. And that's what our picture looks like. Let's see if we did a good job. Okay, I think I still have the previous one in decimal, so we'll close that and look at what happened here. So this was the function, it was a cosine transformation again. So we're going to start with y equals cosine of x. Okay, we are going to first take that x and divide it by 2. So it got wider, the period got larger. I'm going to zoom out so I can see where 3 pi is at least, because that's going to be on my marker in a minute. The next thing we did with our graph is the amplitude. So it got taller, we got that 2 up there. Then the next thing we did is the phase shift. So we had, in the original, we had it written unfactored as minus pi halves. So in my purple graph right here, that's what we have right now showing. And then we are going to upshift it 1. And so there we go. We didn't solve for the x-intercepts. Turns out they look like -pi3, 7 pi3, 11 pi3. So another funky pattern in terms of some kinds of pi3s that we'd have to solve for if we were going to look for them. So it's a single pattern. It's a double pattern repetition instead of a single pattern repetition, again, just like last time. So luckily this time they didn't ask me to find x-intercepts, and I was able to make a accurate sketch, dropping that x-axis down to that light blue line of what the graph looks like.